Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Good afternoon, everyone. Today we will delve into the important and timely topic of plastic degradation processes, focusing specifically on the breakdown mechanisms and their environmental persistence. Plastic pollution has emerged as one of the pressing environmental challenges of our time. To understand how plastic can harm ecosystems, it is essential first to explore how these materials degrade over time. At the outset, let's define what we mean by plastic degradation. This process refers to the physical and chemical breakdown of plastic materials into smaller fragments, which can eventually lead to the release of various chemical constituents back into the environment. We will begin by discussing the first major category of degradation mechanisms, biodegradation. Biodegradation occurs primarily through biological means, and it can be defined as the breakdown of organic substances by microorganisms, such as bacteria and fungi. One of the key aspects of biodegradation is microbial activity. Researchers have found that microorganisms play a pivotal role in breaking down plastics into simpler substances. Notably, there are specialized bacteria that have evolved to digest certain types of plastics. For example, studies have identified specific strains of bacteria capable of degrading polyethylene, a common plastic type. It is worth mentioning an in-depth study conducted on the biodegradation of polylactic acid, a biodegradable polymer used in various applications such as packaging. Researchers saw significant degradation rates, which were promising for taking steps towards more sustainable plastic use. Moving on, another significant process is known as photodegradation. Photodegradation is the alteration of the chemical structure of plastics resulting from exposure to ultraviolet light. Through photodegradation, plastics undergo chemical changes which can lead to the weakening and eventual breakage of polymer chains. An important point to note is that while photodegradation can reduce the size of plastic litter, it does not necessarily eliminate the plastic problem. Let's further explore oxidative degradation, another critical pathway in the degradation of plastics. This process predominantly occurs when plastics are exposed to oxygen under various environmental conditions, and can cause severe damage to the molecular structure of the plastics. Oxidative degradation leads to the alteration of polymer chains, resulting in embrittlement and fragmentation of the materials. Factors such as environmental exposure to atmospheric oxygen or various pollutants significantly influence this process. Next, we cannot skip discussing thermal degradation. This involves the breakdown of plastics due to exposure to high temperatures. During thermal degradation, molecular bonds within the plastic material can break down, resulting in products such as gases, oils, and char. It is crucial to recognize how temperature impacts degradation. Higher temperatures generally accelerate the decomposition process, making this an important consideration, especially in waste management and incineration of plastic waste. In considering these mechanisms, we also need to examine the synergistic effects on plastic degradation. A synergistic effect arises when multiple degrading factors, such as heat and light, combine to increase degradation rates significantly. For instance, plastics that are exposed to both exposure to UV radiation and high temperatures may degrade more rapidly than those subjected to one condition. Let's shift our focus to some real-world examples that illustrate these breakdown mechanisms in practice. One concerning case is the degradation of plastic products in aquatic environments. In marine conditions, plastics do not simply disappear. They may undergo biodegradation by marine microorganisms like bacteria. However, it is a slow process, and much of the plastic tends to fragment into microplastics instead. Microplastics have been detected in the stomachs of various marine creatures, raising significant concerns regarding bioaccumulation and the potential passage of harmful chemicals up the food chain. In another case, researchers studied the impact of thermal degradation in landfills, where high temperatures may be naturally present due to decomposing organic matter. Certain plastics have shown accelerated breakdown when subjected to these high-temperature conditions. As a supportive measure, policymakers around the world are pushing for stricter regulations surrounding plastic production, use, and disposal, emphasizing the use of biodegradable alternatives. In conclusion, understanding plastic degradation processes is crucial for addressing the environmental persistence of plastic waste. By analyzing mechanisms such as biodegradation, photodegradation, oxidative degradation, and thermal degradation, we have begun to elucidate how plastics can persist and how we can potentially mitigate their impact. Ultimately, as we introduce more sustainable materials and promote responsible plastic disposal methods, we can begin to de-emphasize the negative environmental impacts associated with traditional plastics. By combining scientific research with community efforts, we maintain hope of reducing plastic pollution and creating a healthier planet for future generations. Thank you for your attention, and I hope this lecture has enriched your understanding of plastic degradation processes.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.